So in this problem it says I have a 25% juice concentrate and it is mixed with a 70% juice concentrate. It doesn't say how much of either one. It just says they are mixed. It says the combined mixture is 40% concentrate and a total of 25 gallons. How much of each type was used in the mixture? So if I call this one amount X, this one is going to be 25 minus X gallons. Because I know together they have to make 25. So whatever I use in this one is going to be 25 minus that amount. So what I know is that I have 0.25 of some amount plus 0.7 of 25 minus some amount equals 0.4 of 25. So now I have my problem set up. I can just go ahead and multiply. So I have 0.25x, 0.7 times 25. So 0.7 times 25 is 17.5 minus 0.7x and then 0.4 times 25. So now I can go ahead and solve. I'm going to minus the 17.5 over to here. And these two will combine. So 0.25 minus 0.7. So that's negative 0.45. And 10 minus 17.5 is negative 7.5. So I divide each side by negative 0.45. So negative 7.5 divided by negative 0.45 gives me 16 2/3 gallons. So now to figure out how much the other one was, so that's the 25% with 16.67 gallons. To figure out the other, I can just go 25 minus that. So 25 minus my previous answer is 8.3. So this is 8.33 gallons. So those are my answers. 25% was 16.67 and the other was 8.3. I was just remembering that I hadn't done the previous two problems on the third page, so I'm going to go back and do those. So number 22, if I want to get this problem done without fractions, I'm going to multiply this by y on top and the bottom. So now I can get rid of the y's and just realize that y cannot equal 0. So I get rid of the denominator. So I have 17 plus y plus 32 plus y equals 100y. 17 plus 32 makes 49. Y plus y makes 2y equals 100y. So I minus the 2y from each side. I have 49 equals 98y. So now I divide it by 98 and y equals 1/2. The mistake a lot of people make is they go 98 divided by 49. Realize you're dividing by 98 to get the y alone. So make sure you do that. Make sure you go 49 divided by 98 is 1/2. 23. It says after 1 year, the interest from a $10,000 investment is $508.75. The money was invested into accounts with simple interest that had rates of 4.5% and 5.5%. How much was invested in each account? So I know the interest is $508.75. Simple interest, principal times rate times time. So I have two of those, one for the 4.5% and one for the 5.5%. So the principal on the first one I don't know, so I'm just going to call it x. The rate is 0.045, that's 4.5, and the time is 1 year, so I don't even need to put the 1. On the second one, I know I put in $10,000, so if I take off X amount of that, this one I'm going to have 10,000 minus X dollars. So if X would have been 3,000, this would have been 7,000. So realize that it's just a way of going around this of saying, I know I had 10,000, one of them is going to be X, the other is 10,000 minus X. This rate is 0.055, and I know that these interest rates, the interest gained from these two, totals to be $508.75. So now I distribute, I have 0.045x. I go to my calculator, 10,000 times 0.055. And it tells, well, it's too many fives. So 10,000 times 0.055 is $550. So plus 550 minus 0.055x equals 508.75. So now I'm going to combine these two, and that makes negative 0.01x. I'm going to minus my 550 to the other side. That's going to make a negative 41.25. So now I just divide by negative 0.01. So a negative divided by a negative goes away. 0.01 just really moves the decimal place to the right too, since it's just 0.01. So x equals 4,125. So remember the x is the 4.5%, so that's 4,125. The other is 10,000 minus that. So if I go 10,000 minus that, I get $5,875. Together they make $10,000. So those are my two answers that we're after for problem number 23. So on 25, you're supposed to solve. I have a variable squared equals a number, so I can just square root it. So x equals plus or minus 12. And that's it. On 26, again, I have something squared equals a number, so I square root it. So I have x plus 3 equals plus or minus 9. So in other words, I have x plus 3 equals 9, x plus 3 equals negative 9. So then I minus the 3, x equals 6, minus the 3, minus the 3, x equals negative 12. (27) I have an x squared and an x, so I want to get this equal to 0. So now you should be checking to see if it factors, or if you don't like using factoring, you're going to use the quadratic formula. If I try to factor, if you like this method, 6x squared negative 35, that makes negative 210. So what multiplies to be negative 210 adds to be 11. 21x minus 10x. 21 minus 10 is 11. This top row is all divisible by 3. That's divisible by, so 2 times 3 makes 6. That's 7. That's negative 5. Or if you want to do it a different way, you could replace 11 with those two numbers. So you have 6x squared plus 21x minus 10x minus 35 equals 0, and then factor by grouping. First group's divisible by 3x, so that makes 2x plus 7. The next group's each divisible by negative 5, and that makes 2x plus 7 again. Take out the 2x plus 7s from each of those. You're left with 3x minus 5. So you get the same thing that we have over here. Once you get them factored, you can put each factor equal to 0. So now I minus the 7, minus the 7. 2x equals negative 7. Divide it by 2, and x equals negative 7 halves. Add 5. 3x equals 5. Divide it by 3, and x equals 5/3. 28, it says to distribute. Before I can distribute, I need to take the negative out. So I have I square roots of 11 times the square root of 22 minus I square roots, and I'm going to break that down to be 4 and 3 and 2 and 2. So I'm going to have 2I square roots of 3. So now when I distribute, I have I square roots of 11 times 22 minus 2I squared square roots of 33. 11 times 3 is 33. I didn't know what 11 times 22 was off the top of my head. Plus, it's also easier to break this down and see that there's a pair of 11s that come out. So I have 11I square roots of 2. The I squared changes this to be a positive. So that's plus 2 square roots of 33. Normally we write it so that we have the whole number, or the real number, the one without the I, followed by the I. So this is the conventional way to write it. Either one would be correct, but this is the correct order that we have it in. On 29, because I is the square root of negative 1, we cannot leave a square root on the bottom of a fraction. So we multiply top and bottom by 3 plus I. This is called rationalizing the denominator. When you multiply by the conjugate pair, that's the fancy name, is rationalizing the denominator. But anyways, so now on the top, 4 times 3 is 12. 4 times I is 4I. 3I times 3 is 9I. And 3I times I makes 3I squared. So that's the top. On the bottom, we have 3 times 3, which makes 9, plus 3I. Because these are conjugate pairs, we know this middle stuff's going to go away, minus 3I minus I squared. So we know that this middle stuff goes away. I squared makes that turn into a plus 1. So really what I have on the bottom is 10. On the top, this positive 3I squared turns into negative 3, so I have 12 minus 3, which is 9. 4I plus 9I is 13I. Number 30, I'm going to do the same thing. I'm going to take the I out of these first, and then I'll distribute. So 2 times 4 is 8. 2 times I square roots of 2 is 2I square roots of 2. I square roots of 2 times 4 is 4I square roots of 2. And I square roots of 2 times I square roots of 2 is plus I squared times the square root of 4, which is just 2. So this I squared times 2 turns into a negative 2. So 8 minus 2 is 6. And 2I plus 4I makes 6I square roots of 2. On number 31, you are just subtracting, so they need to have common denominators. So 2/3, if I multiply it by 2 on top and bottom, becomes 4/6. So 4/6 minus 1/6 is 3/6, which reduces to be 1/2. 3/5 I minus 2/5 I makes positive 1/5 I. (32) again, we're going to rationalize the denominator, get rid of the I that's on the bottom. So I multiply top and bottom by 7 plus 3I. So on the bottom, that's 49. I know my middle stuff goes away, so negative 3I times positive 3I is negative 9I squared. That turns into a plus, so I really have 58. because 10 and 58 are each divisible by 2, I'm going to do that. So 10 divided by 2 is 5. 58 divided by 2 is 29. So my final answer is 5 times 7 plus 3i all over 29. So on the previous problem, we rationalized the denominator. The numerator also had some i's with it, so we distributed it out. If it just has a whole number like 10 was, I don't distribute it in. I just leave it outside the parentheses and then look to see if anything cancels. If it doesn't cancel, then I would leave that whole number on the outside of the parentheses. So on 33, you're supposed to solve for x. My recommendation is to say let u equal x squared plus 3x. And then I see that this problem is just really u squared minus 14u plus 40 equals 0. So I added this 40 over to the other side to make it equal to 0. So now I can see that this is going to factor, because 40 is 4 times 10, and 4 plus 10 makes 14. So if I make them each negative, a negative times a positive, a negative times a negative makes a positive. And when I add them together, negative 10u and negative 4u make negative 14u. So now I have it factored. I could set it equal to 0 and solve, but because I know that u is x squared plus 3x, I'm going to go ahead and replace that right now, so that I have x squared plus 3x minus 4 equals 0, and I have x squared plus 3x minus 10 equals 0. So now I have two problems equal to 0. So I take this first one. This factors to be x plus 4, x minus 1. So 4 minus 1 makes 3. 4 times negative 1 makes negative 4. I set each of those equal to 0. I get x equals negative 4 and x equals 1. Over on the other side, if I factor these, 5 times 2 is 10. 5 minus 2 is 3. So x plus 5, x minus 2 equals 0. So x equals negative 5 and x equals 2. So all four of those are my answers. And again, I used u substitution. You don't have to if you want to try to factor this out and just realize that this is going to be in parentheses, and you'll get to this same point right here. So 34, I'm going to do the same thing. I'm going to let u equal d to the 1/3. So really what I have is 3u squared minus u minus 4 equals 0. Again, this factors. If you want to use little boxes, you can. 3u and u. If I put a negative 4 here and a plus 1, that makes 3u minus 4u makes minus 1u, negative 4 times. So that worked. So if I solve each of these, I get that u equals negative 1, and u equals, I'd add the 4 and divide it by 3, and u equals 4/3. So now what I'm going to do is replace that d to the 1/3 equals 4/3, and d to the 1/3 equals negative 1. So to get rid of the 1/3 power, I multiply it by 3, because then those cancel off. So that's cubed. So 4 cubed is 4 times 4 times 4, which is 64. 3 cubed is 27, so d equals 64/27. And when I cube this one, negative 1 times negative 1 times negative 1 is negative 1, so d equals negative 1. Realistically, we should plug those back in and make sure they work, since it is indeed a cube root, to make sure that those answers work for what we are working with. 35, I'm going to get this stuff that has the power alone, since it's the only thing that has a variable. So I add 3 to each side, and I get 2x minus 1 to the 3/2 equals 125. So to get rid of the 3/2, I'm going to put this to the 2/3 power. So I could write it like this and do the same thing over here. So these powers cancel off, and I'm left with 2x minus 1. Now over here, I have the cube root of 125 squared. That's the 2 on top. So the cube root of 125, that's 5 times 25. So the cube root of 125 is 5. So I have 2x minus 1 equals 5 squared. This 2 on the outside is still here. So 2x minus 1 equals 25. Add the 1, add the 1. 2x equals 26, divide it by 2, and x equals 13. So that's your practice test. Go ahead and work through that, and good luck.